Hello everyone! Please, first of all, if you see this video with low resolution or very blurry, I would recommend you to check the YouTube visualization quality with the configuration button and set it to 1080p, and also display the video in full screen. Okay, in this video, I just want to illustrate how to perform and interpret results for a multiple structural variance submission analysis with POSTRE. Before entering into POSTRE particularities, I want to comment that a multiple structural variant analysis can be interesting on different scenarios, such as the ones represented in this slide. So we may have multiple structural variants coming from different patients, or we may have multiple structural variants coming from the same patient and we are interested in filtering those which are pathogenic, or a combination of both scenarios is also possible. In order to upload multiple structural variants to POSTRE to be analyzed, we must arrange the structural variant information in a tabulation separated file. We need 1 row and 7 columns per structural variant. Briefly, the first 2 columns contain the information for the breakpoint 1, chromosome and coordinates. The second pair of columns contain the information for the second breakpoint, again, chromosome and coordinates. And then it is also required to provide the type of a structural variant, its associated phenotype, and the structural variant unique identifier. More information can be found in POSTRE user guide and GitHub page in order to know more about how to generate this file. For the example that we are going to discuss, we have used a file which is also available on POSTRE user guide and GitHub page with the following information. We have 10 different structural variants coming from 8 individuals. 7 individuals provide 1 structural variant, in this case from patient 1 to 7, and 1 individual, patient 8, provides 3 different structural variants. In addition, we can see that even though most of the structural variants are associated with only one phenotype, such as head, neck, or craniofacial alterations or limb anomalies, we have one patient, patient 3, whose structural variant is associated with 2 different phenotypes, with head, neck, and limbs, because this patient presents both craniofacial and limb anomalies. Okay, now let's download this file and analyze it with POSTRE. We have it here on the user guide, as I was saying. I just downloaded it. I have it now on my downloads folder. So we just come to the menu, come to downloads, and get the file. I just uploaded it and submitted. Okay, upon result generation, different sections containing the results are provided. A detailed explanation of the information associated with each of the sections is provided here on top. Please check it if you want to know more. Briefly, in the results per structural variant and phenotype section, we find a table with a pathogenic prediction for each of the structural variants and associated phenotypes analyzed. We can also see when pathogenicity is predicted, which is or are the genes predicted to be causative of the disease. In addition, for all the candidate genes, for all those genes whose sequence or regulatory domain has been altered, we also have the maximum pathogenic score computed for each of them. If you want to know more about how pathogenic scores are computed, please check the pathogenic score explanation file that you can find here. Coming back to the table, just to point some results, we can see that pathogenicity is predicted for all the structural variants analyzed except for the structural variants 2 and 3 from patient 8. And well, indeed, these structural variants were obtained from healthy control individuals, so as expected, they have not been predicted as pathogenic. I just put them here to show that POSTRE can help to filter structural variants by pathogenicity. We can also see, for instance, that for the structural variants in patient 1 and 2, the gene predicted as disease causative is AP2-alpha. And for patient 7, 2 genes, NR2F1 and MEF2C, are predicted as disease causative. We can also see that for patient 3, pathogenicity is predicted for both associated phenotypes, head, neck, and limbs. And SOX9 is the predicted disease causative gene in relation with both phenotypes. If we move on to the second table, this one corresponds with an aggregation of the pathogenic predictions per gene, phenotype, and pathogenic mechanism. It can be seen that AP2-alpha in relation with head, neck, or craniofacial alterations, it has been predicted as disease causative gene in 2 different structural variants. In one of them, through a long range, through an enhancer-mediated pathogenic event, and in one of them, through a coding pathogenic mechanism. And in the following columns, we have the identifiers for the structural variants where these predictions have been performed. Thus, a pathogenic long-range effect for AP2 alpha has been predicted in patient 1, for the structural variant 1, and a coding pathogenic event in patient 2, structural variant 1. The following table contains the information of the structural variants as uploaded to POSTRE. Alright, upon doing this exploration of the results, let's suppose we are interested on getting more information for any of the structural variants. We can do that very easily from the submission box provided at the bottom of the page. So let's suppose we want to get details about patient 7, structural variant 1, where POSTRE predicts pathogenicity and identifies 2 disease causative genes. To get more information, we just have to copy the structural variant unique identifier, put it in the submission box, and submit the job. And now, we just got the results as when performing a single structural variant submission job. So this was all I wanted to tell you. Thank you very much for your attention.